All right, so we're going to talk about the derivative function and rules of derivatives. So for a nonlinear function, so this is not a straight line, right? The slope changes depending on where you are at the curve. So like at this point of the blue curve, my slope is negative and going down. Here, at this point, the slope is negative, not as steep. Here, my slope is a horizontal line. The slope is 0. Here, the slope is a positive value going up. Here, the slope is a positive value, and it's even steeper. Okay, so if you're given a function, we can create a function that represents the slope. And that's called the derivative function. If at any point you want to hit pause and copy more down, you should do that. Okay, so let's do an example. So here we have a function y equals x squared, and the derivative is equal to 2x. I'm going to talk about how to get this function for the derivative in just a minute. Okay, so when x is equal to 3, find a point on the curve and the slope of that point. So first of all, to find the point on the curve, I would plug in 3 in for x squared, and then we would end up with 9. So the point on this curve would be 3, 9. Okay, so that would be up here somewhere, right? And then if I wanted to figure out the slope, I could plug in 3 in for x, so then we get 2 times 3, which is 6. And so the slope at y equals x squared at 3, 9 is going to be 6. So if I've got this this quadratic equation of y equals x squared, if I went to the point at 3, 9, then I would have a slope here of 6. So as I go further up, the slope gets steeper and steeper. Okay. So let's talk about how did we get this equation for the slope, for the derivative. So to get the slope, the equation, to get the derivative function, which gives me the equation of the to find a slope, we use something called the power rule. So if I've got my function f of x equals x to some power, what basically happens is this power here becomes the new coefficient, and then this power here decreases by 1. So just like I said, the power becomes the coefficient, and then the power decreases by 1. So the derivative function is an equation that helps you find the slope of a function. Okay, so this notation, f with a little prime x, is used throughout this unit to represent the derivative. So whenever you see this little thing here, this means the derivative. So we would call that f prime of x. You might also see the derivative referred like this, dy dx. Next example. So what if I've got f of x equals a number, right? Like 5, for example. Well, f of x equals 5, or y equals 5, gives me a horizontal line. Well, you all should know that the slope of a horizontal line is 0, right? Okay. And this example we just did a minute ago, f of x equals x squared. If I'm using the power rule, this power decreases by 1 and becomes the coefficient. So if this power decreases by 1, it becomes x to the power of 1. And then this becoming the coefficient, we now have 2x. Okay, so let's see. When x is 0, I plug in 0 in here, my slope is 0. That makes sense. When x is 1, if x is equal to 1, then my slope is going to be 2, right? And when x is 2, I plug that into my equation, and I'm going to get 4, right? And you can see that makes sense because the slope is getting steeper and steeper as we go that direction. Now what if x is -1? So if x is -1, I plug in to my derivative formula and I get -2. Right? And if I plug in -2 in for x, we get a slope of -4. And that makes sense because the slope is going down. Okay, now let's talk about a bigger function. So here I have y equals x cubed. So once again, the power becomes the coefficient, and then this power decreases by 1. Finding the derivative is fairly easy. Okay, now what if I've got x and then there's already a number there? Well, you know this power is going to be decreasing by 1, so it's going to become a 2, and it would become the coefficient, but we still have this 4 here, so we multiply 4 times the coefficient that we're bringing down, and then we end up with f of x equals 12x squared, or f prime of x equals 12x squared. Let's see, what if we got an equation like this? So here's my equation. You can see some wild curve, and if I want to find the derivative, power decreases by 1, so we're going to get x to the 4th, and here we have 4 times that power that got moved down. So this power has decreased by 1, and that power got moved to the front. And now we've got plus 2 times this power gets moved to the front. Power decreases by 1. Now this has a power of 1, right? So if that decreases by 1, we know the slope of y equals x is going to be a slope of 1, right? Because there's no coefficient, so we're going to put a 1 there. And you could think of it as, you know, x to the 0, really, but x to the anything to the 0 power is equal to 1, isn't it? So we could just call this 1, right? So what's the final answer for the derivative? Equals 20x to the 4th plus 6x squared plus 1. All right, let's find some more derivatives. Okay, now we haven't talked about doing a fraction, but if we think of it like this, I could convert this to a negative exponent, and that's equal to x to the -1 power, right? Because if I want to move it from the denominator to the numerator, we can make the power negative. Now, our rule says the power decreases by 1, and this value here becomes the new coefficient. So this is going to become the new coefficient, so -1, and then the power is going to decrease by 1. So if that's decreasing by 1, this is going to become to the power of -2. So just like I said before, this power becomes the new coefficient, and then this power decreases by 1. So if we subtract 1, we end up with this. Okay, and you could also write it like this, -1 over x squared, right? Either answer is the same. Okay, now what about this one here? Well, let's first write it with without the fraction. So we've got f of x equals x to the -3, right? Okay, now let's find the derivative. So the derivative is equal to, the power becomes the coefficient, -3, and the power decreases by 1, so we end up with -4. Okay, and if I wanted to write this without the negative power, I write it like this, and I've got -3 times 1 over x to the 4th. and you could leave your answer in either way unless it specifies no negative exponents. Okay, and then if I've got one separate like this, you have to just do the derivative of each one separately when they're separated by the plus sign. So let's take the derivative. No, but before we take the derivative, let's just rewrite these with negative exponents. So we have f of x equals x to the negative 4 plus 3x to the negative 5 plus 2x to the negative 6. Okay, so I'm just rewriting it with the negative exponents. Okay, so now I'm going to say first derivative. Okay, this power becomes the coefficient, negative 4, and then the power decreases by 1, so we got negative 5. Okay, this power becomes the coefficient and gets multiplied by the 3. So negative 5 times the 3 is negative 15. And then the power decreases by 1, so I get x equals negative 6. And then this power becomes the coefficient. Negative 6 times 2 is going to give me negative 12. And then the power decreases by 1, so we get x to the negative 7. So once again, derivatives give you an equation that will give you the slope. Okay, and if we wanted to write it without the negative exponents, I would write it like this. Equals negative 4 over x to the 5th minus 15 over x to the 6th minus 12 over x to the 7. Okay, if you need to rewatch it, please do. Hit pause if you need to, and this should help you with your homework.